So today again we are talking about something that is relevant to managing stakeholders, but taking a slightly different approach. So we talked about, we know stakeholders are important because the case studies have showed us that. We've talked about how to identify them, and yesterday we talked a little bit about how to negotiate with them. But sort of a parallel, not mutually exclusive but complementary approach is also this notion of something called design thinking, which I think is very important to both designing projects as well as managing stakeholders. So what we're going to do in the class today is talk a little bit about design thinking. Again, what I'd like to do is sort of do some, you'll have some presentations to make, we'll discuss, I'll show you a short video that we can all watch for about half the class. And then the second half, again, we'll pair up like yesterday and you guys can actually do a live design thinking exercise, okay? All right, so we'll start off with group 1, I think we're cycling back now, right? So group 1, Sudeep, you're going to do this? Okay. Now, Sudeep, are you going to present both the readings? Okay, do the first one. Who's presenting the second one? Okay, so after the first one, we'll come back in and have a discussion, and then, so you're presenting the Srirangapatnam case study. So yeah, so come and present yours and then we'll discuss and then I'll have you come in.
Hi everyone, today I am going to present on topic design thinking for social innovation. This is part of an review paper presented by the Stanford students. First in this, they are going to talk on the case of Nandi Foundation run community treatment plant which is near Hyderabad in a village. First they talk of an woman, daily she carries an water from the near local water. She is capable of carrying 3 gallons of water on her head, but there is Nandi Foundation which is supplying water cans of 5 gallons of water. Even though she knows that the water from the local supply is unsafe, she still takes that water itself. The basic reasons for this are 5 gallons of water can't be carried by her. Even though if she can carry, the design of that can is rectangular shape and it is not suitable for carrying and all. And the cost of the water supplied is about 10 rupees and for them it is still a privilege to pay 10 rupees for each can. And for this the Nandi Foundation was able to design the plant for cleaning and all to supply the potable water, but still they have missed the opportunity of gaining the customers like these people who aren't buying this water. The main reasons can be considered as the customers are not involved in this design process, or else like they didn't ask the clients what are the needs of the clients. If they have incorporated the needs of the clients, they could have addressed this problem. And even if the people from the foundation, if they have gone to the field and they have took the opinions of the clients and all, they can't address this because they are already fixed their minds like this is what the needs of the people and this is the particular solution for this problem. So traditional methods can't solve this type of problems. For this there is a new approach called design thinking approach. Design thinking has been used in some companies as well right now. Like Apple products and all, they are using design thinking. They will get a collection of reviews and all from the people, they will incorporate into their design. By using all these reviews from the people, the products can be innovative and their brand will be different from the other brands where other brands can't be able to provide what the needs of the people are. This is basically like incorporating the people's needs and providing what they want. So we are getting an high impact solution from the bottom rather than getting imposed by the higher authorities, like they are planning what the solution is and giving that solution to the people. Like design thinking at work. Here there is an Terry Stern who is a professor. He is a founder of Positive Deviance. Here there is an example of malnutrition in Vietnam. He has solved this with an small, it's like there are people in this Vietnam state, like more than 40% of the children are affected by the malnutrition. Their age is below 5, and from this they have gone to the place in Vietnam and they have asked the people who all are affected and all, and from that they have found some 4 or 5 groups of people who are not affected. It's like it is a positive deviation from the other. It's like remaining all are affected and these are not affected. So they want to study on them why they aren't, why these children are good and what is the nutrition they are following and all. From this they have known that they are even having crabs and all. They are giving their children these crabs and all food. So they are getting digestion and all. Something is happening and finally they are getting the problem solved. So this one they have incorporated into the other people as well. Other people also follow this same principle and all. By this implementation, 80% of the children were recovered from the malnutrition within 2 years. So from this, what this professor calls this as like these 4 people in that community are different from this. It's like how they behave and all are different from how the remaining community behaves. And this is called as positive deviance. It's like there might be some people with negative deviance also, but we have to take the positive thing and which will be helpful for the people, and that one if we can incorporate into this and we can provide a better solution for the people rather than having some medicines for nutrition and all that can't solve. This problem can be solved by cheaper cost and all. Next, origin of design thinking. Even there is other example like this problem can be, as I already said that people-centered approach. This is a people-centered approach, like we are incorporating how the people are reacting to specific problem and the positive deviance part of it. Here the solution might not be applicable to the entire world, but it can solve the specific situation. Since there is an example here like in Africa there is an malaria has been growing largely, and they have done an research and finally they have got into the hospitals and all hospitals supplied nets for free, and finally they have kept even one thing like only for children or mother who is pregnant they are supplying this thing, and finally these people or children the affect rate of malaria in these people has decreased, but for old people are getting affected. When they see in the cause is like old people are not getting these nets for free of cost, and rather these other shops are not selling these because many people are getting it free of cost. So if I supply my business go at loss. So only specific problem that small children are not getting affected by malaria has been solved, but not the complete community problem hasn't been solved. Next, coming to design thinking approach. In this there are 3 spaces. We will call them as spaces rather than steps because they can be of iterative order or else they can't be in a linear fashion. We can do it in first we can have an idea, we can go and see if it can be implemented, or we can get a problem from otherwhere if we have some idea where we can implement that problem and all. Next, inspiration. Classic point at starting is like brief. We will be having an idea of what the problems in the complete city, and we will take a problem from that and we will try to solve that problem. First, when we have a complete set of the problem, later we will have an approach how to solve this problem and all. We will ask our clients or people in our company to come with an ideas and all. If we have many ideas, from that we can check which can be feasible or not. And finally there is an IDEO which is an human-centered design toolkit which is available on websites and all, which can help individual to take a design thinking process easy. Ideation is like after spending a lot of time in designing process and selecting a specific idea, we have to implement that idea. For that and all, we have to design steps and all. What steps we have to take to implement this idea and all. This can be done in the ideation part. For this, as I already said, that we need a diverse group of people, like some people from law, some people from designing, architect and all, so that they can come up with different ideas, and we can discuss what problems will be there and different approaches from different people, and finally the best idea will be selected among all these, and that can be implemented. Implementation stage, it is an important stage, as we can get new challenges, we will face new challenges while we are implementing this problem. Like I already said, in Africa stage, like only people or children, malaria rate in children has been decreased, but for adults and all it hasn't been decreased. Like only some specific problems might be solved in that, so we have to reconstruct the designing part after the implementation stage as well. Many social enterprises are already using these methods for designing. As I already said, Apple has been using this method, but many people are fearing to use this method because they might get into losses. This is not a conventional approach, this is some different approach from conventional thinking method and conventional designing process. Finally, we will be able to solve this problem by design thinking as well, but we have to overcome fear.
Okay, thanks. So Sudeep has a lot of information on design thinking, but I want to sort of just start off with a very simple question, right? So design thinking is essentially a process of design, right? And one thing we need to understand is when we think about design, since most of us in this class at least are engineers. Alexander, you an engineer? Okay, so all of us are engineers. We tend to think of designing physical things, right? So we civil engineers design bridges, mechanical engineers design automobiles, all of those kinds of things, but design can also apply to a process, right? So if you take something like Swachh Bharat, okay, it still has to be designed as a process, okay, so or Sarang or Shastra or Civil CEA Fest or whatever it is you want, right? So now the question is, we've been designing things for a long period of time, and we now have this new paradigm called design thinking, okay. So what is design thinking about? Why is it any different from, I mean, you guys, many of you have taken classes in design, right? Even in the last few years in the civil engineering department, right? So what are we talking about that's, so how does conventional design work and what is new about design thinking? So essentially, I think if you look at the process of design, and most of you have gone through some kind of a design class, right? So you've designed concrete beams and you know whatever. So if you look back at the process, right? First you're given some inputs. So typically in the civil engineering case, you're given some loading conditions, right? So this is, I mean, this is a, this is a bridge, this is the kind of traffic that's going to go on this bridge, and so you have some idea of live loads, dead loads, etc., earthquake loads, wind loads, whatever. So I give you some data, okay? What do you then do with that data? You take that data and you then do all of these complex calculations, okay, and you come up with a design for whatever it is, beam, column, bridge, whatever, right? And the design of course have many components. If you are designing one member, then it's very simple, right? So what are the dimensions of that member? Is there any reinforcement, whatever? If you are designing a whole bridge, there are many sub aspects to that design, right? But then you come up, and what is the expectation, right? Is the expectation that this is an implementable design, or is the expectation that this is, just a prototype or just a trial? When you've done designs, right, and you come up with an answer, it could be in your structural analysis class, right, or concrete design class. When you come up with an answer, is the expectation that this is the right answer, or is the expectation that this is a trial solution? So what is your expectation when you are designing it? So if let's say I'm the client, right, so you're designing it and you come up with this calculation. Do you expect me to say fine, good? I mean, of course, let's say somebody checks your calculations and your calculations are fine. Do you expect people to say, okay, yes, good, let's go to the next stage? Or do you expect people to say, interesting, go back and try out another iteration? What is the expectation? So the expectation is that you have solved the design problem, right? The expectation, you may have made mistakes, etc. But what you are trying to achieve is the perfect solution first time. Right? So I'm giving you conditions, you're thinking through, you have the engineering knowledge to design, you are expecting to come up with a perfect solution or a near perfect solution, right? In an ideal world, your solution will be acceptable, right? And if it is not acceptable, then it is in your mind, it is possibly because you've made some mistake somewhere, right? You've not taken in some parameter or you've made a calculation mistake. In other words, it's an error. So this is the traditional design process. This is the traditional design process for civil engineering. This is the traditional design process for designing software systems, right? Same thing. You have a consultant who goes in and sort of understands, spends some time, understands what, how the bank functions, because they want to develop a computerized banking system. Then you come back and you shut yourself in with all your other programmers and software architects and all of that, quality control, testing people, etc. And you come up with a system. The idea is that you will launch it on the server or the mainframe or whatever of the bank that you're working with, and it will run, right? And if it doesn't run, there's a bit of a debugging, but what you would like to do is eliminate the chance that there are bugs, right? So ideally you want to sort of get to a point where you have the perfect solution, right? So design is sort of essentially relatively linear. Gather requirements, use your expertise, come up with hopefully what is the best solution. But what happens unfortunately is that it isn't that linear, primarily because this whole thing of gathering requirements is not so trivial. Okay, so when I say this is the load on the bridge, what am I talking about? Is it the peak load on New Year's Eve where there are fireworks from the bridge? Is it sort of the the average kind of, can that loading condition change as the economy improves or goes down, right? So there are no precise answers to what is the load on the bridge, right? It isn't as if the bridge is going to have that load on every single day. Okay. Similarly with the software design example, you might have observed a few people work, right? But have you really observed how everyone works? And therefore, are there functionalities, for instance, that you may not have observed that might be critical, like I need only 3 gallons of water, I don't need 5, right? So whenever I try to get these requirements, I often fail to get the complete picture, right? If I'm good enough, I'll get a partial picture. I'll understand how the bank works. I'll more or less understand what's required of the bridge and all of that, or I'll understand how many liters on average or gallons on average a person needs. But there are always all kinds of exceptions, to the rule. I'll give you a couple of examples that I've been through recently. One is our own workflow system at IIT, right, which is now relatively stable, right? But when it was first launched, very similar process. Consultants came in, I think they spent some time with the administrative offices trying to understand how courses work in IIT, how leave works or whatever, and put in a system. But then when many of us tried to go in, we found that our specific requirement was not met. Okay, similarly, another slightly more concrete example, I am on the editorial board of a journal, right? And so what ends up happening is people submit papers and I have to find reviewers for those papers, right? So there's a workflow in place. Submit paper, I find people, I send it out to people, I give them a deadline, comes back, sort of works well in the ideal case. 2 people send in reviews, then the third person says, sorry, I'm too busy, I'd like to cancel. Okay, so now I have to figure out, now ideally what I would do is I'd find a third person, I'll give them a sharper deadline, etc. This system, for instance, said, look, as soon as people have given reviews, you can't invite more reviewers, right? Which is a logic that for me does not work. Okay, so these people have talked to people to design this system, probably works well in 80% in some cases, certainly doesn't work well in mine. So you have all of these kinds of systems and products and processes and so on that people design, which do not necessarily work because it's very difficult to get a hold of all of these requirements. And then very often you end up with what you have, the classic comments of what you have done is useful, but it cannot be used, right? So yeah, I mean, nothing wrong in what you sort of did, but I can't really use it, right? Or you did what you were, I mean, there were a few of these other sort of clever wordplay kind of phrases, right? So what design thinking does is it says, let's turn this entire thing on its head, right? So right now you have a linear process. You say collect the requirements, and then you're the genius, right? So you go ahead and because you understand programming better than anyone else, you understand engineering design better than anyone else, whatever it is, right? You go in, shut yourself in a room, and come out with the right solution, right? Because you're a genius, right? You understand the space, you get the data, you should come up with the right solution. That's the traditional design philosophy. Design thinking says let's just switch that upside down. Right? Let's assume that we will never get the right requirements, right? And therefore, if we don't get the right requirements, it follows that we will not have the perfect design, right? So therefore, number one, as somebody, I think Yamini, you were pointing out, it has to be iterative, right? I welcome iteration, right? Traditionally, if I go to a design and somebody says, no, change this, then very often it sort of means that I've failed, right? I made a mistake, right? So here, there are no mistakes, right? We iterate. Now therefore, if I have to iterate, I have to make one other change, right? If it takes me a year for every iteration, right, it will take me forever to get agreement on anything, right? So typically if I want to design a metro rail, I give you a design contract, I expect you to take 6 months to a year to design, okay? Then if I come in and say, oh, by the way, this doesn't meet the need of many of our passengers, yes, it meets the need of some people, but by the way, your platforms have to be wider, they have to be longer, you need to have other kinds of access ramps, and I give you all of that feedback, which you may not have collected earlier. And if it takes you one more year to go ahead and do that design, then we'll be stuck here forever, right? By that time, some new technology would have come up and you would say, oh no, I need these kinds of telecommunication devices, so go back one more year, right? So therefore, not only I have to be iterative, but I also have to be rapidly iterative, right? So rather than taking a long period of time and shutting myself down and coming up with the perfect design, can I shut myself off for a very small period of time, come up with essentially an iterated prototype? I understand this is a prototype, I have no expectation that this will be the correct design, right? But I bring it back to you quickly to get your feedback, right? So in other words, I'm now going away from trying to give you a finalized design to giving you designs that elicit feedback. The purpose of the design is no longer for you to say wonderful, congratulate and clap. The purpose of the design is for you to give me feedback and say, oh yes, you took these things into account. I hadn't told you these because it never struck me, but now it does now that I've seen it. Why don't you sort of do one more iteration? And because these iterations are fast and rapid, right, you have a different design cycle that's much more rapid, prototype focused, faster, and therefore includes more and more people's needs. And therefore, a couple of you were saying design thinking takes into account more needs than the traditional design process. That essentially is how it happens, right? So that fundamentally is the design thinking process. I'll show you a slide and then I'll show you a video, right? So essentially if you follow, there are variants of design thinking. I tend to like the one that the D school or the design school at Stanford came up with to sort of describe this. I mean, all the other variants, the one that Sudeep put out is a variant of this, right? So essentially they say, look, you go through 5 phases, right? So this is phase 1, right? Empathize, which means learn about people that you're designing something for, right? It looks simple, right? But it isn't. I mean, look at the average home builder, okay? The person who's building these apartment complexes, and think about how much time are they really spending understanding the kinds of people who are going to live in that building. How much time do you think they're spending understanding the kinds of people that are going to live in the building that they're going to build, right? So I am some developer, XYZ developer. I'm going to develop high-rise apartments or whatever, townships, sell them, etc. How much time do you think I'm spending on understanding what these people do, right? Often very little, right? Often you have an idea of, oh, you know, people tend to like 3 BHK, 3 bedroom, hall, kitchen, you know, apartments with attached bathrooms, 1 car park, maybe a small puja area, whatever. So you have this kind of templatized ideas on which you design, and then you actually find out that there's quite a bit of redesign that ends up happening, right? Because, you know, young people have a very different view of what the houses should be like, right? So they're probably looking at, you know, entertaining people, you know, buying 75-inch flat screen TVs and calling everyone over to watch, I know, a football match or whatever, which means fundamentally you need to have wall space to do those kinds of things, right? When you have young kids, you're thinking about safety, right? When you're much older, you're thinking about possibly a variety of different things. So perhaps depending on who you're thinking for, the design needs to be fundamentally different, right? So this is essentially phase 1. It sounds obvious, right? Think about who you're designing for, but often don't really get to do. Once you do that, you can actually start defining the project brief, right? Which are your requirements on the project, right? So you don't just say, okay, can you just tell me, give me the requirements. You actually spend considerable amount of time learning about these through a process called empathizing, which essentially involves what one might call ethnography, right? Which is the study of people, which means ideally you would immerse yourself in a social setting to sort of understand what people are doing. So if you were to design an old age home, right? One thing is, you know, let's talk to people about what older people want, okay? And yeah, obvious things come to mind. Yeah, obviously they can't climb stairs, so there needs to be, you know, access, this, that, you know, whatever. They're a bit clumsy, and therefore I need to design whatever. But when you actually live with older people, you might find a lot of other clues on what they do for entertainment, how they engage with people, and therefore how the space that they are in should be. You could do the same thing for this classroom, by the way, all right? So we have sort of a notion of what classroom should be like, but maybe if you actually sit in a class, then you have a better understanding of whether you have the right kind of ventilation, the right kind of spacing between benches, the right kind of acoustics, all of that come to mind, right? So after that you define, right, and then you kind of brainstorm, and this is where your intelligence come in, your skills come in, you sort of design. But, and here's where it becomes interesting, you start developing prototypes, right, which means in as little as three days, a little as a week, little as a fortnight, you come back with something, right? And the something may not be one of these reams of blueprints, right, that you see in engineering trailers and so on. The something might be a sketch, it might be a thermocol model or whatever, it might be a a small BIM prototype, and we'll talk a little bit about that later, but it's a prototype, right, on which you say, okay, this is what it's going to look like, right, what do you think, right? Now that there's something physical in front of you, you can actually engage with it, right? So one of the causes of delays in construction is because people say the clients make changes all the time, okay, and contractors are very upset, everyone's very upset that the client is making changes, and therefore more work is being extended and projects are being delayed, okay. But if you talk to clients, right, and say, why are you making changes, right, the client essentially says, look, when you showed me a bunch of blueprints, right, I couldn't understand what this thing looks like. Now when the thing is actually in front of me, now I understand that the conference room is no longer as large as I wanted it to be, right, that the bathrooms are too far away on one side and it's highly inaccessible because this is where most of the people are going to be working, right. So while yes, that information was there, right, but it's only so much that I can get from 2D drawings. When I see it live is when I really start getting these ideas, and so now I want to break open the conference room, I want to shift the washrooms to this side, etc., which is a highly time consuming and expensive process, right. But this happens because I now have a prototype. Unfortunately, in this case, the prototype is the real thing, right. Wouldn't it be nicer if I were able to build better prototypes that people could touch, feel, etc., come up with these ideas much quickly. So then I have essentially a testing phase. I am under no illusion that my prototype is going to be a final design, right. In fact, when I built my first prototype, mentally I probably am very clear that I'm going to build at least 14 more prototypes before I get to the final design. So there's nothing lost. I'm not embarrassed, I'm not sort of taking it badly that you're giving me adverse comments on my prototype. That's what I want, okay, in this process. And now I start going through this cycle. Okay, so I tested it, okay, I got some ideas, I go back, I ideate, I come up with a second prototype, right. I test that again, okay, maybe it fulfills some more needs, but maybe there are a few other ideas that come out, so on and so forth, over and over, until I actually get a design that I know that works for people, which I can then manufacture or fabricate or whatever, right. So essentially this is the design thinking process. Traditional design is somewhat linear, right, give me the requirements, I'm the expert, I'll shut myself in a room and I'll come up with something which will work, right, and what history has shown us is it really doesn't. Whereas this design thinking process essentially says, don't even think you can design it right the first time, right. So you're going to take a long time to understand what people do, so go through a rapid set of iterations so you can get those ideas out better and you're more likely to come with a design that is useful, okay, make sense? Okay, so in this entire process that we're seeing on the screen here, where do you think you'd spend the most amount of time? Okay, or each of you have picked one of the 5, but somebody said empathize. Who said empathize, right? How many said empathize? I agree. I think this is the key and most difficult part, really understanding, trying to understand what people want, right? And we'll do a small exercise little bit later in the class where essentially I'm going to have you guys pair up and design, a wallet for one another, right? So a wallet, a purse, whatever it is you guys want to design, right? Something which you carry along with you, okay? But a lot of things that we design, you really need to understand what it is that you're designing for, what do people need and want, right? And so what are the concerns? And the reason this is important, I think, in an infrastructure class is there's no reason, I mean, you can apply this to design. So we'll see now in the video, but the mouse here apparently was designed using this kind of a design thinking philosophy, right? Because obviously I want something to move around, but what should it be like? How big should it be? What are the functionalities? So it's sort of a unique thing, right? It has a certain form factor, it has a certain standardized, there's a key role in the second. And most of us, I mean, how many of you are relatively comfortable using this? Right, most of you are relatively comfortable. Anyone particularly uncomfortable? Right, I'm sort of normally quite comfortable using this, right, and that's because it's come through this kind of a process, right, where you understand, ergonomics of people, what they want to do, questions in terms of how far can it be, how quickly must it move, etc. Right? So you use this to design everything from, could be walking sticks, could be this. We'll see an example of a shopping cart in just a second. But the question is, why can't you use the same principles to design infrastructure? Right? So if you're designing a dam and part of that dam is for hydroelectric power, part of it is for irrigation, etc. Have you really thought about the various people that you're trying to design it for and what they want out of the project? Right? So what kind of electricity requirements do they have? Will the dam fulfill it? What kind of irrigation requirements? What kind of drinking water requirements? What other kinds of requirements are there in the facility? Right? So the same idea of empathizing and then maybe trying to come up with prototypes, and we'll talk about how that's done in the infrastructure case, could work here as well. Correct. So, and that's exactly the point that so your argument is Conoco used the design thinking approach, right, but failed. My argument is Conoco did not go anywhere close to using the design thinking approach. The design thinking approach, and we've talked about this earlier as well, would have said, let's talk to some people, let's quickly turn around not a 3,500 page document, but a 5-page or 10-page concept plan on what we want to do. Let's start getting more ideas, right? And then go through that process iteratively. But of course, before doing that process, spend a lot of time talking to the NGOs first, right? Before you even go ahead and show them something. So that would have been empathize, rapid prototyping, all of that, right? But Conoco did almost the opposite. Hardly spoke to anybody and then came up with something that was so over-designed that people didn't believe that this was a prototype to test. So, and therefore the complexity, so the point is that infrastructure projects have more stakeholders involved. So the complexity of doing the design thinking exercise is obviously order of magnitude different compared to designing a shopping cart or whatever, where you have, a few people that you're trying to design it for, or a few categories of people, whereas here you have displaced people, you have flora and fauna that you're actually destroying in the case of this dam, you have sponsors, financiers, etc. So it's order of magnitude difficult, and therefore you may not be able to do it in exactly, and therefore there are also time constraints, and therefore you may not be able to do this exactly as systematically as you would like. But the point is, there's a philosophy here, right? There's a philosophy of designing a project which says, don't just go ahead and design and come up with detailed project reports and cost estimates and schedules and all of that and say, here, this is what we're going to do, right? Can we do it in a more iterative fashion, right? Can we spend a lot more time than we normally do, right, understanding what the needs of the stakeholders are, right? So very often you have governments in a hurry to launch projects and they say, okay, let's give out this contract, in 6 months I need a design. Right? Can we actually spend more time on the front end of these projects doing that empathizing, and can we go through some kind of an iterative phase on the design, and we'll talk about the Srirangapatnam case in terms of how that could be done on an infrastructure project. But this is essentially it. Traditional design, linear, design thinking, spend more time empathizing, understanding your customer, right, and spend more time iterating rapidly, rapid prototyping and iterating over designs. You are more likely to A, end up with the right design, or B, end up with a design, but who cares whether it's right or not, the design that people accept because they feel that we've been part of the process, right. So last class we talked about the FAIR process, right, and how people often need to be engaged to find acceptance, right, and design thinking could be something that enables this FAIR process argument in infrastructure, okay. And I actually brought this video with me, so if I can, I'll just play it out.
We went to IDEO, the product design folk, and said, take something old and familiar, like, say, the shopping cart, and completely redesign it for us in just 5 days. ABC News correspondent Jack Smith tells us what happened next.
9 in the morning, day one, and these people have a deadline to meet.
So welcome to the kickoff of the shopping cart project.
This is Palo Alto, California, in the heart of Silicon Valley, and these are designers at IDEO, probably the most influential product development firm in the world. IDEO has designed everything from high-tech medical equipment to the 25-foot mechanical whale in the movie Free Willy, and the first computer mouse for Apple. Smith ski goggles, Nike sunglasses, NEC computer screens, hundreds of products we take for granted.
The point is that we're not actually experts at any given area. We're kind of experts on the process of how you design stuff. So we don't care if you give us a toothbrush, a toothpaste tube, a tractor, a space shuttle, a chair. It's all the same to us. We want to figure out how to innovate by using our process, applying it.
Project leader is Peter Skillman, a 35-year-old Stanford engineer. Project leader because he's good with groups, not because of seniority. He's only been at IDEO for 6 years. The rest of the team is eclectic, but that's typical here. Whitney Mortimer, Harvard MBA. Peter Coughlin, linguist. Tom Kelly, Dave's brother, marketing expert. Jane Fulton-Suri, psychologist. Alex Kazaks, 26, a biology major, who's turned down medical school 3 times because he's having too much fun at IDEO. Safety emerges early as an important issue.
22,000 child injuries a year, which is, and so they're hospitalized injuries. I mean, there are many others.
And theft. It turns out a lot of carts are stolen. As the team works, it becomes clear there are no titles here, no permanent assignments.
And the other side says, gives us a lot of help, says, be safe. I'll give you a big red ball on a post, and that says you're a big guy. If you got a ball, you're a senior vice president. You know, what do I care? The desk, the red ball, it's all the same. In a very innovative culture, you can't have a kind of hierarchy of here's the boss and the next person down, the next person down, the next person down, because it's impossible that the boss is the one who's had the insightful experience with shopping carts. It's just not possible.
The team splits into groups to find out firsthand what the people who use, make, and repair shopping carts really think.
Okay, go.
The problem with the plastic cart is the wind catches it. Yeah. And these things have been clocked at 35 across the parking lot.
Oh, man, that's actually a pretty good point. The trick is to find these real experts, and so that you can learn much more quickly than you could by just kind of doing it the normal way and trying to learn about it yourself.
From everything I read, these things aren't that safe either, you know? So probably the seat itself is going to have to be redesigned.
One of the interesting things for me is looking at how people really don't like to let go of the cart, except for the professional shopper, whose strategy is to leave the cart at various places.
3:30 in the afternoon, and the group is back at IDEO. There is no let-up.
Each team is going to demonstrate and communicate and share everything that they've learned today.
A shopping cart has been clocked at 35 miles an hour traveling through a parking lot in the wind.
We were in the store, 2 hours, and it was truly frightening just to see the kind of stuff going on.
You ought to designate some people to make damn sure that the store owner's point of view is represented.
After 9 straight hours, the team is tired. They call it a day.
So,
Everybody cool?
well, that's great. Thanks a lot. We had a great time today.
IDEO's mantra for innovation is written everywhere. One conversation at a time. Stay focused. Encourage wild ideas. Defer judgment. Build on the ideas of others.
That's the hardest thing for people to do, is to restrain themselves from criticizing an idea. So if anybody starts to nail an idea, they get the bell, you know.
The ideas pour out and are posted on the walls.
Oh, the blind, the privacy blind. Like when you're buying 6 cases of condoms, no one sees. If it doesn't nest, we don't have a solution.
Organized chaos. It's not organized. What it is it's focused chaos.
Vote with your Post-it, not with an idea that's cool, but with an idea that's cool and buildable. If it's too far out there and it can't be built in a day, then I don't think we should vote on it. Enlightened trial and error succeeds over the planning of lone genius.
Enlightened trial and error succeeds over the planning of the lone genius. If anything sums up IDEO's approach, that is it. Worried that the team is drifting, what can only be called a group of self-appointed adults under Dave Kelly holds an informal side session.
4 or 5 teams. 4 or 5 teams, and we give each team a need area. It becomes very autocratic for a very short period of time in defining what things people are going to work on.
If you don't work under time constraints, you could never get anything done because it's a messy process and go on forever.
Back at the shop, it is 6 o'clock, and the 4 mock-ups are ready for showing.
Baskets also can be, if you think you will have more volume, baskets can be put in.
A modular shopping cart you pile hand baskets onto. A high-tech cart that gets you through the traffic jam at checkout.
That you could mount a scanner on the shopping cart so that you as the customer, as you pull it off the shelf, would scan each item.
One that's built around child safety, and another that lets shoppers talk to the supermarket staff remotely.
Yeah, where can I find the yogurt?
But the adults, again, decide more work needs to be done before the mock-ups can be combined into one last prototype.
Why don't we have all the carts come up here for a second?
I think you take a piece of each one of these ideas and kind of back it off a little bit and then put it in the design.
The design is still not there, But there's another motto at IDEO: fail often in order to succeed sooner. And some of the team will be up half the night trying to put together a design that finally does work.
Good.
There it is! So we took the best elements out of each prototype.
The cart, which is designed to cost about the same as today's carts, is different in every other way.
What do you think?
Well, I'm very proud of the team. I think it's great.
Does this work for you?
Works for me great. It's also beautiful.
The cart's wheels turn 90 degrees so it can move sideways. No more lifting up the rear in a tight spot. And you shop in a totally different way. The bags are hung on hooks on the cart's frame. Remember, there is no basket here.
At first, I was a little shocked, but I think you have some fantastic ideas here. It needs a little refining, but I think that it's great. I mean, we would want them.
She also gave us some really good comments about how we can make this thing better.
A lot of hours. Also, an open mind, a boss who demands fresh ideas be quirky and clash with his, a belief that chaos can be constructive, and teamwork. A great deal of teamwork. And these are the recipe for how innovation takes place. This is Jack Smith for Nightline in Palo Alto, California.
Okay, so that was a pretty good rendition of the overall design thinking process. So clearly you guys saw part of the empathizing phase where you had these guys go into the store and actually interview shoppers, watch how people were shopping and interview everyone, right? The security guards, the store owners, the shoppers. So shopping cart is not just for shoppers, right? Security guards also have a role to play. It's a lot of empathizing, then they come back, they define, ideate. You saw prototypes being created relatively quickly. None of them were really polished, finished, but just to sort of give the feel. And of course, they didn't do as many iterations because this in some ways was staged in some sense, in the sense it was done as a challenge, it was done to sort of create that video, etc. So they didn't do as many iterations as they might have. But you could clearly see a few iterations before the final shopping cart came out and some testimonials from people, right. So that's a very quick run through of how the design thinking process works, which you can contrast with yourself in terms of how the traditional process would have worked, where somebody says, okay, this is what I want with a cart, right. It should be able to carry 300 kgs of groceries, right. And so you go in and you design and you make sure that flexure and torsion and all of those are met, etc. And then you come up with a cart which is fine but may not have taken care of child safety, right. May not have taken care of the fact that as somebody says there are these ramps and it's going down at 30 miles an hour, can actually do some damage, right. So all of those kinds of things. So the traditional design process would still have come up with a design, but maybe this design process helps come up with a better design, and maybe there's not that much of a time difference either because you're rapidly prototyping, right. So that essentially is the essence of the design thinking process. Now to see how it might potentially be used in an infrastructure setting, Yamini, why don't you come up and talk to us about the project in Srirangapatnam.